Yo, what's up, everybody? Welcome back. Today we are working on our hand-rolled Wayland client, and we have been working on trying to get GPU buffer sharing between applications. So the idea here is we've been writing a Wayland client, and the way a Wayland client works is you have kind of like your window manager. I guess this is kind of like Wayland as a whole, not just the client. You know, in him, I'm like got this like window in here, right? Like a little paint canvas with like a little X, and he's got some like stuff in him, right? How does this window get created? Well, the process that is like drawing all of the windows has like this socket on him, and an application will talk to this socket through the Wayland protocol. Okay, so when I make my app, I just basically ask him like, hey, could I like, I don't know, could you make me a window, and like what is his size, and like could you let me know when he closes, and like let me render some stuff to you, right? Within the Wayland spec, the only real way to share like an image between processes is we create this like shared memory handle. So we made one in like dev shm, which is just like a tempfs file, which means that like the file lives in RAM essentially, and we just like write pixels into this thing, right? And then what we can do is we can, over this connection, we can send like a file descriptor over to the other side, and so then the other side knows, hey, we have a guy that we'd like to draw, right? He just like takes the pixel memory and writes it to the window essentially. If we want to draw this guy on the GPU and then copy the whole image over to the Wayland compositor, then the Wayland compositor copy pastes this image back onto the GPU and then draws him. That's kind of fucking stupid, right? So instead, what they have is in the Wayland protocol, they have this extension called Linux DMA buff. And so you can ask your compositor, hey, do you support Linux DMA buff? And if he does, then you can use this like OpenGL interface to ask your OpenGL context to create a file descriptor that represents a GPU buffer. This is not the same as like this like memory mapped or memory backed image. This is like a GPU resource that you have a handle to, and you can send that handle over to another process and say, hey, can you like put this back? And so what we've been playing with is we have this example where we have this like server and a little client, test client. And this is an example of us doing that exact thing. So here is, well, one of these windows created this texture and turned him into a file descriptor with this like EGL API. It's called EGL create image. And then he like turned him into, sorry, that creates an EGL image. And then there's like EGL export something, I can't remember. But that basically turns it into like a Linux DMA buff file descriptor. We send that over to the other side, re-import him, and then draw him on the other side. The goal for today is to kind of like take this concept and integrate it properly into our Wayland app with this. So we're missing a couple pieces here. Here we kind of generated the texture kind of by hand, right? So we just like went pixel by pixel and set the colors here. We kind of want this texture to be drawn by like OpenGL commands so that we can like render animations and stuff, right? So there's that piece. We need to basically set it up so that we need to do some like set up like an off-screen rendering context. So usually EGL will create a context for you. When you type like GL draw arrays or whatever, it will like draw to some like kind of implicit buffer. In our case, we're not going to have that implicit buffer, so we have to there's no like backing window for it to draw to. So we have to set up this like concept of we can create an OpenGL context, but OpenGL, you don't know where we're drawing this to. Just pretend that there's no surface that we can draw to. That's like a thing that we can do. So we're gonna have to try experimenting with that a little bit. And then when we have that, then we can try like binding to a frame buffer, rendering a thing, sending it over the wire with like ZWP extension protocol thing. So that's the plan of action. So I forgot to fix my to-do. I thought I did. So we're gonna have to say our first step is gonna be finish render to texture in OpenGL land. Then render to texture from off-screen context. then integrate. Let's get this guy kind of set up right. And there we go. I think we're chilling. Let's get ready to rumble. 05:15. Okay. So yesterday, I guess I should also mention at the end of stream, we did not quite make it. We did not quite make it to a functional thing. It turns out that there's this like GL flush call that has to happen after we create the image. This was pulled from this guy's example. Someone sent this to me right at the end of stream yesterday, so we kind of missed it. But in here, he has a documentation, a little comment here that says, the next line works around an issue in the Radeon SI driver. If you're having problems with texture rendering until the first texture update, you can uncomment this line, GL flush. So I don't really know why that fixed it, but it does. So we just have to, that was like the kind of missing piece at the end of last stream. And so yeah, we should have a working example. So let's move on to, right now we are generating our texture by hand. Let's generate it with some OpenGL draw calls. So our code's really fucking messy right now. I would kind of like to try to clean it up a little bit as we go. So maybe we'll create a... How do I want to do this? Maybe we'll create like separate applications. I feel like that will be easier to manage. And then we're going to have to extract some functions. So this file will be written egl wayland.xg.c. That's fine. And maybe we just comment out this main function for now. Maybe for now. And we'll kind of make like functions to do the pieces that we want to do. So let's see. So we had client C. He's going to look very similar to this example from before. He's going to look similar. We're going to have main. And I guess I'll just kind of copy this. And we'll kind of see how it's going. So this came from some example that we stole on the internet for a quick EGL plus Wayland setup. So we have done some stealing here. But that's okay. We'll live. And okay, what needs to be done here? So this is going to be the client automatically. We don't need this like if server stuff. And so kind of we're just going to go straight into whatever it said we were going to do if we were the client. Here, we are not actually going to spawn a window at the end of this, I don't think. I think we are just going to use the context we have now and figure it out from there. So I want a like function here to generate a texture. So we'll say gl uint gen texture. And this will kind of just do, set up our texture IDs and stuff. So this is going to be like a gl uint texture, and he will return that thing. Which means that in client.c, we should be able to be like, hey, make me a texture, please. Gl uint texture is equal to gen texture. Boom. Boom, boom, boom. So that gets this out of the way. I guess here we will kind of call this something. We'll figure it out in a minute. This stuff will have to get factored out, but it's fine for now. Then we just kind of upload the texture data. Okay. And then we need to get some of these like extensions. Extensions. So I think what I want to do here is I kind of want to like wrap these in a define. So I want to be like bind EGL extension. Extension, and I want like a global, or I want like a type as well as a name. And that should let us do something that's like static this thing. Sure. So this is going to be like type, name. And I don't, is this allowed? I think it is. We'll see. Uh, so if we do like replace this, if we say bind, what is this? What do we call this? Bind EGL extension. So we know that we want EGL create image KHR. Hashtag name without the quotes. Is that how this works? I know that, like, yeah, I guess that stringizes the thing, huh? That feels like what I want. Does feel like what I want. And here we're gonna say that the type name is the same as this, but it starts with PFN and then ends in proc, I think. And then it looks like this is okay now. It looks like. We need to do the same thing for this function. Bind EGL extension. It would be nice if we could automate the PFN and proc thing and uppercasing, but I doubt it's that straightforward. So we're just going to skip that for now. Here we're not going to try to render the texture at all. Maybe we will. Maybe we'll keep that stuff in here. Maybe we will. I'm not sure. And then this becomes PFN and proc and all uppercase. Does everything else in here kind of work? Okay, so let's just try to see if we can compile this. So we'll have a client comes from client.c and EGL on wayland.c, xdg shell c, and xdg shell.h. Depends on all these things. And it's going to look very similar to what we were doing before. It's going to be called client, and he is just going to also have to have client.c. And then we'll have our server comes from server.c as well. I'll call this server. Okay, let's just try to quickly bang out. Well, I guess let's try make client here. Make sure that that works. No rule to make target EGL on wayland.c. It's EGL on wayland xdg. My bad. He's mad because duplicate symbol. Really? Why? I'm actually confused. So this is only in here once. Yeah, I'm actually quite confused about why this doesn't work. Defined at this place. And then here, duplicate symbol defined, at 320. 311 and 320. Oh no, this is 320 is just duplicate called twist. Oh, I'm an idiot. It's because if I'm including the C file, then I'm building it twice. Okay. So server.c should look very similar to client.c. I know we're kind of like taking some shortcuts here, but I'm not trying to get too crazy. I don't really care that much about this code base. I'm just trying to make it like kind of work okay, you know? So let's get out this client section here. He's going to actually bind the thing, and let's just see if this all still works. I'm just trying to make it so that it's like at least somewhat workable, because it was getting really bad at the end of stream yesterday, so. And if without an if. True. So now our server, he's still looking for argc, which we don't want anymore, so we'll do that. server, client. Looks like we're still chilling. Looks like we're still chilling. Oh, oops. I ran the wrong thing here. So it's actually not chilling. It's actually not chilling at all. So our client.c is mad about the texture that we created, which is a little confusing to me. I feel like we didn't change much here. So he's asserting somewhere that num planes is 1 here. This query mesa thing did not work anymore. Which is surprising. Surprising indeed. Because I feel like we didn't really change much. Ugh. What a pain in my ass. What a pain in my ass. So let's copy from here. This internal texture ID isn't used. Oh. Oops. That's why. Wrong fucking element we were trying to pull from. Make. Client. Make client. Make server. Client. There we go. Much better, much better, much better. So server, client. There we go. There we go. We're chilling, we're chilling. We are chilling. Okay. So now, hopefully, this is like a little bit more usable. Can we at least also, can we abstract away this like send texture to server? I feel like this needs to be kind of pulled out. So maybe we'll even say like make server connect to server. Call it for now, that's fine. Which is gonna do the like socket creation and connection. And return this. And then we will take in the socket here. And we will do this stuff, I guess. So this we'll call this send FD to server for now, because that's kind of all it does. So this is going to take the socket FD and FD to send. And then all we have to do is like make texture file descriptor. Which is going to be like int make texture file descriptor. And he's going to take in a texture. And that's just going to be the stuff we had kind of here. This stuff. Yeah. All of this. Cool. So I guess we also need like a state thing here, which I don't know what it's called. This is kind of from the code we stole. It's called client state. And then these guys need to be arrows now. Okay. And cool. Cool. So this has some file descriptor that we need to export. Oh, from here. Return FD, boom, boom. And this needs to be an arrow, boom. All right, hopefully this is the last of like the refactoring stuff, just because we did leave ourselves in a pretty poor state yesterday, but now it should be as simple as connect, make texture file descriptor, which takes in our texture and state. Then it was connect to server. Oopsies. So this is int socket fd is equal to this, and then it was send fd to server socket fd and texture fd, like this. All right, now I can actually read what is happening here, which is a big win for us. Big win. And it still works. Chilling. I shouldn't laugh, dude. It's like fucking fart collectors. Chat says greetings from North Korea. It's just so stupid. Everything in that is just so fucking stupid. And it made me laugh. And that's annoying. Okay, so I guess it was kind of like really more like clean up yesterday's mess. And now we are at try render texture from OpenGL. Okay. Okay, so before we were kind of creating this texture like this, instead we want to create our texture by drawing to it from the GPU. So I believe that that requires this concept of frame buffers, I believe. So like, we should be able to bind a frame buffer right to the frame buffer, and then send that frame buffer over to the other side. But I think we might want to take a couple steps in between first. I think, because I need to remember how this works. So it looks like there's this way you can like make frame buffer. Probably returns a GL unit. So if I remember correctly, you can kind of picture this as like when you call like draw, when you do anything like GL clear. This like writes to something somewhere, right? Like if you try to clear with black, it'll like do this somewhere. Typically this does this to like the screen that you're drawing on. But you can kind of say like, hey, can you render this to like my texture instead? And the way that works is you don't actually render straight to the texture. You actually render to this thing called like a frame buffer. And the frame buffer points to a texture as its backing storage, if I remember correctly. So I believe we have to make a frame buffer, attach the texture to the frame buffer, set the buffer as where we're writing to, and then we can like look at that stuff after instead of just presenting it on the screen. So that is my recollection here. So let's kind of copy paste some code from Learn OpenGL. So I think this is a GL uint frame buffer object. And we probably just want to like back this with our texture. So he also says, let's bind this thing as a frame buffer. Cool. And then somewhere, is that all we have to do? How do we like attach a texture? Here we go. So you can say like, hey, I have a texture and I would like to attach my texture to the frame buffer. This is how I remember it. So here we make a new texture, and the texture, he sets this up as like an RGB color texture, sets some parameters on it, and then attaches it. So this is kind of like the call I'm looking for. And I guess we'll make a frame buffer from this texture. Let's kind of like start here and see if that makes sense. So this says like, hey, when you try to draw to like the color buffer, please write that out to me, please. Is there anything else we have to do here? Render buffers are kind of like specialized frame buffers, if I remember correctly. And do they have like an example here somewhere where they just kind of like, yeah, so they bind a frame buffer, they clear, they draw stuff, then they do a second pass where they unbind the frame buffer and then render again. So if we take our texture and we say GL make, what do we call it? We call it make frame buffer. Okay. We say let's use this texture, and can we do like GL clear color as maybe like RGB. So we'll make it like we'll try to make a green, fully green texture. Which means we need like GL color buffer bit. I believe if we do this and we run our little experiment again, we should see a completely blue thing show up on the other side. If everything works, which it might not, right? Who knows? Let's fix our makefile to have like an all here that depends on server and client. And then when I make this, it should do everything we need. Okay, so the server does, no code has changed, but the client now, he now sends over a completely green buffer, which is a huge win for us, right? And you can see like the client is exited, so this is a completely green buffer being shown on the server from the file descriptor passed over. Big win. Big win. So that's actually kind of way simpler than I thought. We're also missing this piece where there are like parameters that are sent over from the client, or sorry, that need to be sent over from the client. So if we look at the server side, when he creates this image, he kind of like has all of these attributes that he needs to say that like this texture is like a this texture level one isn't here, but like this is the color format of this texture, and here are the width, here's his width and height, and here is where he is in the memory that you sent over, and like this is how long a line is, and like here's some modifier pieces that we sent over. So I think, does it make sense? How do I want to tackle this? We could say that the thing that we want to do now is kind of passing these should be passed over the socket so that we can like apply those parameters. Maybe I will just kind of allow those to stay fixed as they are, because I want to kind of move on, keep moving forward. This is kind of like scratch code anyways. So yeah, let's just keep moving forward. Let's move forward. And so the next thing I want to do is in our client code, I want to look at the fact that like we are in our client getting our EGL context through Wayland, and I want to not do that, right? So say like you don't have a window system at all, you should still be able to use EGL to create an OpenGL context that is just like raw talking to your graphics card. And that's kind of, well, raw is kind of strong, but like instead of going through like the window manager, he just says like open dev DRI card 0, right? Like in the same way that we did when we were raw dogging, he's going to do something similar, and then he's going to call ioctls on this thing directly. So let's do that. Let's do that. So I believe we should probably just look at like our EGL and Wayland example, and he has this like EGL in it somewhere. Let's just kind of like copy paste this. And we'll call this like we'll call this like off-screen EGL in it or something. Off-screen EGL in it. Okay. Okay. And he takes in a client state. We probably don't need that anymore because there's nothing related to Wayland that we should need anymore. This should kind of be like from nothing. So before we won't create a window. And I think that we should be able to call like EGL get display with like no surface like, existing display. Or maybe we just call that like platform display with null. I seem to remember there being something here. EGL, off-screen rendering. EGL default display. I remember being able to call get display with no display maybe. No display. If no display connection is available, no display is returned. Oh, right. So we maybe just will use no display in future things. Can you call like EGL? So they create a display. Then they initialize that display. So can we call like EGL initialize with no display? I can't remember. I thought I had this in my head. Maybe we'll ask the idiot. Can you give me an EGL initialization example for off-screen rendering? Let's see. So he does call EGL get display. EGL no context maybe is what I'm thinking of. No, he still does that. Okay, no, let's say, sorry, to be clear, I have no, I want it to work from a virtual terminal using dev DRI. I believe it's very similar. He does it like this. I remember there being an extension. That you can use to not do this. This is not what I've done in the past. EGL off screen. Headless EGL. Maybe this is what I'm looking for. Headless. This is probably, I just forgot the word I'm looking for. Nope. We'll ask it again and we'll use the word headless. That should help. Could you make me a headless EGL example? No, a Windows system. No, I want headless. Fuck, man. Headless rendering EGL. This is frustrating. Because I thought I knew how to do this. Surfaceless? That also sounds familiar. Yeah. Thank you. To make a context current by passing EGL no surface for the write and read surface in the call to EGL make current. The motivation is that applications only want to render to client API targets should not need to create a throwaway EGL surface just to get a current context. The state of the EGL ES context with no default frame buffer is provided. Okay, right. So here I say in EGL make current, I still need a display. But I don't need a surface. So this is the part. Okay. Right, so they had... Right, okay, so they made an EGL window. And so I guess the play here is we call this with EGL default display. Okay. Then we still need to initialize with this display, which makes sense. So what does EGL get display return? EGL get display returns an EGL display. Okay. So this is fine. Then we initialize this thing, and we still need a display for that. We say we want OpenGL. We still use our EGL display. And we want to use the config, a config. So a EGL config like this. We do not have to create a surface. That's the part that we don't need, but we still need a context. Cool. Then we need to make that context current with EGL no surface. This definitely sounds like what I've done in the past. So if we do all this, hopefully we still get this printf here. That's kind of what I'm hoping to see. So I'm hoping to see like we do return here. We don't want a wayland connection at all, actually. Fuck that shit. And let's see what happens. So we still do get an OpenGL version, which is very good. That means that we bound correctly. And so the rest of this stuff will hopefully just kind of still work. Except that when it draws, he's going to render this frame buffer. So I think that everything here should just still work, except now we just don't have any... Do I even need this state thing anymore? I feel like I don't. We use this for make... texture file descriptor. Surely he doesn't need much other than EGL display in here, right? So can we just do EGL display. Oh, he needs the context as well. Okay. It's fine by me. Fine by me. Okay. Cool. So now we need EGL display and EGL context. And then in here, we don't even need this client state thing at all. It's kind of gone. Which means that this guy has like no concept of wayland in here anymore, almost. I guess when we make this, we need to return our like EGL params. So it's gonna have a EGL display and EGL context gets returned here, and then we just return EGL display and EGL context. Boom. Do we need to do like this struct EGL params like this in this language? I think it's something like this, which means that when we create this thing, we can say struct EGL params EGL param equals this, and then here we can go boom, EGL params display, EGL params context. Wow. Looks like it's still working. Look at us go. That's pretty cool. So now our client is actually quite straightforward. There's no wayland stuff in here at all. So now, that's kind of this done. And I guess this feels like all of the pieces that we need to start working with this wayland app extension to let us use this thing that we're making to send to the compositor. We are kind of really making this like big bet that if we do the same thing that we're doing now in this client program, that it will work. But I don't see why it wouldn't, right? If we have successfully taken a buffer, sent it across the wire, reinitialize it, I don't see any reason why that won't work if that other person was not written by us, right? That's kind of like the next piece here. So I think we get back into our wayland client stuff here. I think that's the play. So let me think about this for a second. What's like the easiest next piece here? I guess there's two sides of this to tackle. One is our wayland, Sway main. This thing is written in Zig, right? And when we create this thing, we're gonna have to pass it over using Zig. I think maybe what makes sense for now is maybe trying to keep as much of the code the same. So maybe we'll do like the negotiation here in Zig, and then just trying to kind of call out to a C execute or a C file to create the texture for us, just to reduce the surface of things that could go wrong. I think that makes sense. So let's start by trying to negotiate support for this ZWP Linux DMA buff thing. That I think is what we want to do. So I don't really know how this thing works at all, to be honest. So maybe we start looking for if we just run our little guy. When he starts up, oops, I think we need to do 2 and 1. He lists us what interfaces he supports. And so we should look for this in here. Okay, so that exists. And so this is an object that we can bind to, kind of like a top level, this thing. And he's going to have, we have create params. Well, yeah, what does he support? Create params, get default feedback, get surface feedback. So presumably create params is the thing, because these things sound like messages from the server to us, where this feels like something that we send to the server. So can we look at like the buff, create params says, I'm going to make a ZWP Linux buffer params. What is this? This is a temporary object. It's a collection of DMA buffs and other parameters that together form a single logical buffer. This temporary object may eventually create one WL buffer unless canceled by destroying it before requesting create. Okay. So this is like a factory function, right? This is like, or like a builder. So for each plane, we add this. Oh, sick. Sick. So this matches up, this matches up like perfectly, sorry, with the code that we wrote on our server yesterday. Right? This width, height, file descriptor, offset, pitch, modifier. This has like offset, stride, plane, high-low. So this actually doesn't have the width and height. So the width and height must be kind of like encoded somewhere else. So then he kind of sounded like at the end of this, there was going to be like a create function somewhere. And so this, so create takes in width, height, format, and then the flags. So what are our flags? Y invert, interlace, bottom first. We don't really care about any of that. We don't care about any of that. Cool. So I see, and since this is a parameter on the interface, all of these adds that we did before will be kind of baked in. So the workflow should be, we have access to this top level interface, we create a params structure, then we immediately start like using that param structure to upload a file descriptor, then we create this, but where does the create go? Oh, he comes back in a signal created that has he tells us the WL buffer ID. Okay, that's interesting. In the past, we've made buffers that we pass over to the server side. The kind of like the client has been in charge of all like item allocation. This is the first time that the server is allocated to the thing, which is kind of interesting. Okay. So this is referencing the DMA buffs. And then on receiving this, we destroy the object. Okay, I think I get it. I forgot what time we started this, but we can kind of say that I don't know what we were doing, question mark, or when. And then here we will say we're 43:25, and we'll say implement ZWP Linux DMA buff v1. Okay. So we need to basically ask, when we initialize, we have this section where we say, tell me all the interfaces you support, and I will bind the ones I care about. So we will just add this thing to the list of things we care about. Go, boom, this guy. And when we get that guy, we need to do something special. So we're going to say, like, we are going to bind this thing. Yeah, so try interfaces bind. And we have to, I guess before we do any of this, we actually need to import the header or the XML file that describes this protocol, because we don't have that right now. So we need to download this and say, could you please tell me what types we need to generate. So what we've been doing is we've been kind of like auto-generating some Zig code based off these XML files. So this XML file will have like something in it that says like, I have a function called get top level declaration, right? Or decoration, sorry. And we have this thing that like parses the XML and turns those into functions. So this is Linux DMA buff here. And this is going to generate Linux DMA buff.zig or something, and come from res Linux DMA buff v1. Okay. Then we are going to add this as an import to our root module. And then in main, we should be able to be like, oops, DMA buff, I guess we'll call it. We import this thing. And then when we use it, now we should be able to say that like wherever the heck we were doing that binding, if we see the name of this thing, we are going to bind that to a thing. So we're going to say DMA buff. What was the top thing? Yeah, DMA buff, we'll call it. Try interfaces bind. And this now comes from DMA B something. ZWP Linux DMA buff v1 probably is how this is going to look. Which means that we need a DMA buff to come from that. So this is going to come from DMA B ZWP Linux DMA buff v1. All right. Yeah, he doesn't like this capital B probably. Let's see if that builds. Let's just see if that builds. It does not. Because expected 3 arguments found 1. That's a good point. This needs some arguments. And unsupported interface, right? So we kind of bind these to like runtime types because the like lookup is like when we get a message, it comes in with an object ID, and that object ID tells us which interface to use, but the object IDs are like runtime known. So we kind of have this like bindings of runtime to runtime enum to like compile time type. So here we're going to say that we have the type of DMA B ZWP Linux DMA buff v1 goes to DMA buff. And then some presumably people are going to use this somewhere. So we'll say that this is going to come from a DMA B ZWP Linux DMA buff v1 event parse. There we go. Let's see how happy he is. Nice. That actually builds. So can we actually see any indication that we talked to this guy? I actually don't. Which is a little concerning. So can we like, if I like jump to definition here, this does exist. And we should get some, oh, we log them in lowercase, I see. So if I do this and look for ZWP Linux up above, it does say unused. Which is a little surprising. A little surprising. I might have spelled it wrong. Oh, fuck me. ZWP. ZWP Linux. Oh, maybe it's, we don't log anything. So maybe it's actually just fine. Maybe it is doing what we expect. So let's trying to call this create params thing. And let's just kind of see where that gets us. So when we bind our interfaces, we need to kind of export those as something we bound. So this is going to be essentially this DMA buff. Like this. And down here, we're just going to say DMA buff is equal to DMA buff, or else return error no DMA buff. Cool. Then when we initialize our like main app, we're going to have to like talk to that thing somehow. So we're going to be like, yo, bound interfaces DMA buff. Can we call create params? Hell yes, dude. And what does he think that he needs? This is going to create us, we're going to allocate a new ID for this thing for use with this buffer params thing. So we're going to copy this and say, okay, I would love for our buffer params to be from this. So we're going to register an interface. And this gets like camel cased. Or Pascal cased, I guess it's called. Camel case is with the lowercase initial letter. And then we should be able to be like ID is equal to params ID is equal to buffer params dot ID. And this comes from DMA buff. Boom. Okay, so now we should have this like writer that we can work with. And I guess we're kind of now just like immediately at the point where we can try to like render something with OpenGL, huh? That's what it kind of looks like. Is like we can just start adding and creating this thing. So can we, for now, what's the easiest way to do this? Sorry, let me think for a second. So I guess this guy's going to return us a WL buffer. And WL buffers are how we interact with the wayland drawing loop. So I think it's like something along the lines of you have like surface and the compositor like draws this when you call commit. So this guy is going to be like attached to a buffer. And basically when you call draw, he's going to draw like from this underlying buffer. And this WL buffer is like returned from ZWP interface, right? So he said that when we call create here, he's going to return us this created ID. So that doesn't really match kind of the way that we've been doing things so far. So I think what makes sense for us to do is we're going to have a new step of our initialization. That's going to be create texture back, create GL backed buffers. So usually I think what we did for our like existing animation is we have two buffers, like a front buffer and a back buffer. Once you start like drawing to one, then you're not allowed to use it anymore. Once you like pass one over to the compositor, you're not really allowed to use it anymore. So I believe what this should do is we'll call this like GL buffers. I think we're gonna have some sort of like GL buffers. I guess it's just gonna be like a WL buffer, which is from WB WL buffer. As I guess he's gonna have like two of each of these, one for the front and one for the back. Right, so this is gonna be like this, and then he's also gonna have like the textures. So these would be like U32s essentially. And so what this will let us do is it'll let us say that like as we are flipping textures, we will basically just like we'll render to the texture that is not currently attached to a buffer. I think that makes sense. And I think that there doesn't necessarily have to be more information associated with these. Because all of the like extra information is just like kind of propagated once on initialization. I think. So I think we can do something like create GL backed buffers. Who's going to return a GL buffers. And now we kind of have to integrate with like that C code that we were working with. So client.c, let's try to make sure that this client.c doesn't require anything from EGL on Wayland anymore. So if I just like delete this, He's getting mad. So we're going to include EGL. I'm just going to kind of copy this and kind of see where it goes. So probably we don't need wayland. Nothing wayland needed. We do need GL stuff. So we'll kind of start here. Start here. And he's mad at like gen texture not existing. So we'll just kind of yoinky is what we need out of here. Because I know this used to be common code, but now, and we just made it common code, but now I don't really want it to be honest. So we don't need this EGL in it. We don't need wayland in it. So what do we need from here? We literally just need like this like gen texture stuff, I think. And probably like setting debug callbacks, which I don't know if we're doing. So we probably need this debug callback and EGL callback as well. So let's kind of start here, see what happens. See what happens. I think that we'll kind of move this into Zig code later, but I just kind of want to see how this goes. So I think we also need that bind EGL extension defined. And I guess this probably shouldn't end with a semicolon, to be honest. Okay, so that compiles. That compiles, and now we kind of want to change our like main function here to be something that like returns us. I guess let's do this. Let's do a copy example client.c to source. And what's the goal of this is to like create a file descriptor and texture pair. So maybe we'll call this like gl.c or like gl.impl.c or something, right? Like these are things that we are doing in C to work with OpenGL for now before we convert them to Zig functions. Okay. So what do we want him to do? We want him to be able to create us texture and a file descriptor with that texture. Then I guess we kind of just, we kind of want to do like our GL calls from Zigland if possible. So maybe like our init offscreen EGL init, this can be like an exported function, I think. So maybe we'll call this like source gl impl.h. And we'll kind of just take this and slap it in here. And which means that like he kind of needs to include like EGL, kind of, right? That's kind of what it looks like. Okay. Then we'll have this function offscreen EGL init. Okay. And what else does it have to do? Connect to server, send FD to server. So that stuff is specific. Like this is not what we're doing anymore, because we're doing this kind of like the wayland way. So like send FD to server goes away, connect to server goes away. We don't need any of that shit. Make texture file descriptor. This sounds important still, right? Because the parameters here for add are taking in the file descriptor immediately. So here we'll just pass in the texture as well as the display in context. That's probably fine. That's probably fine. And then he returns the FD. Make frame buffer. Probably, maybe we leave here, maybe we don't. I don't know. I'm really most interested. Okay, main goes away for sure. Main goes away for sure. So maybe we call this like make test texture. We won't worry about like the off-screen rendering stuff yet. We'll just worry about like this stuff. Yeah. Yeah. So then externally we'll create a texture. It'll be like this like red-green thing. We are going to hard code some parameters in here for now, probably, and then we'll kind of slowly extract them. But yeah, this seems fine for now. This seems fine for now. Delete main, I guess, or maybe comment it out. Okay, and then we just kind of make this guy exported here. And this needs to include GL.h. Okay. Cool. Cool. Seems reasonable so far. Redefinition of EGL params, that's true. Fuck off. S text test. Yeah, that's true. That's funny that I didn't even register that at all. I think so fucking phonetically, man. What a pain in my ass. Okay, so we're gonna add a C source file. What do we call gl.impl.c, and then in main we're gonna include. I guess you're not really supposed to do this way, but I can do what I want. So this is gonna be called gl.impl is gl.impl.h, because this invokes Clang twice. So like they suggest putting everything in one C import, but I don't want to do it that way right now. Okay, so now we should be able to be like gl.impl create make text test texture. Oh, it's probably because it was test texture. I think that's like a tongue twister. Text texture. So maybe we'll start without any double buffering or anything. We'll start with one. We'll start with one. So this is just a const texture ID is equal to this. Test texture tongue twister. Test texture tongue twister. Yeah, perfect. And so now we should just be able to like somehow work with this stuff. So he needs to take in like our interfaces. And he's going to be like bound interfaces dot DMA buff create params. Okay. So which means that he needs a writer as well. So where does that come from? Stream. So we're going to use stream and bound interfaces is probably where this is going to go. Probably he needs like the interface registry as well. So stream is net stream. Interfaces is going to be a interface registry. Okay. And this create params comes in with this. Did we not already do this? We did. So this is just going to be over here. I guess kind of this text ready stuff is going to come later. Tongue, fuck, got some Swedish in there because you spelt tongue with a U. Show it to that video, fellow Swedes. I don't know what you're talking about, but that's not for me. So once we create this thing, we should immediately be able to work with it, I think. I don't think we have to wait for anything. So I think we're just going to be like buffer params add. And so now we have to actually like add an FD and a plain index. So FD is going to equal whatever we got from here. So I guess we have like gl.impl did I miss like an important piece here? Make texture file descriptor. We need this to kind of exist in gl.impl.h as well. Which means that we need like offscreen EGL in it as well. So we need like a gl.impl offscreen EGL in it. Then it was like make texture file descriptor. Yes. Which we have here. Cool. Make texture file descriptor. which gets our texture ID, EGL params.display, and EGL params context. This is our file descriptor. So now we have the file descriptor here. We have our offset. So we need to like get some extra parameters here. It's not just this. So the things that we query when we create this thing, we need to propagate up. So we'll call this texture FD or something. It doesn't really matter. Okay. And this is definitely gonna have like the file descriptor, but it's also gonna have like the offset. We should be careful with our types here, probably, huh? So he needs we're assuming one plane for now. We need the color code for DMA as well as the uint64t modifiers. Okay. Then we need the stride and offset as well. And I think everything else is already there. So now we're just going to create our output. Like this. And I guess we'll do like a little 0 initialize him. And then we will just kind of use ret 4cc here. And ret fd, ret stride, and ret offset. Huzzah! Huzzah! Fix me, like, fail if not successful. We'll figure that out later. I guess that should be kind of like here. But for now, we are taking shortcuts because we're in prototype mode. Prototype mode loves shortcuts. I'm back again. How's it going? Not bad, not bad. We are in the process of trying to integrate our texture passing with this Wayland ZWP Linux buffer protocol thing. We've kind of like proven to ourselves that we know how it works a little bit. And we're just kind of moving on. So when we create our backed buffers, this now no longer gets a file descriptor. He gets like params, FD params or something, text params. ZWP params maybe is the best name for this. Things that we're going to send over to the ZWP side. And this comes from ZWP params.fd. Let's just see kind of how much this doesn't build. We need to link against GL and EGL. Sure, that's true. So exe link system library GL and EGL. See where it goes from there. Okay, so mostly fine. So now it's just at 747 in main. Can we just discard this for a second? Because I think that that's going to let it go farther, because things are definitely not fully there. So I guess we can take this by const. In which case, just taking it by value seems totally fine by me. Seems fine by me. Some more missing type implementation, type translation implementation. So we need to take this guy, and when we register him, he's got to have a runtime type associated with him. So we'll just kind of quickly run through all of the places where this thing is used. There's one more here. And the parser now comes from DMA puff params or something. What was it? It's a Linux buffer params v1. Buffer params v1. There we go. I'm just gonna time you out. This isn't like a tech help place. And also, what a strangely specific question. But good luck on your quest, sir. I like the idea of instead of Googling, you're like, I'm gonna go to some random Twitch chat, and we'll click on the computer section because they know computers. It's like, go away. It's not what, like, it's not what we're for. We're working on something else right now, sir. What am I missing? He's mad because expected error union found this. Sure, because he thinks that this can't fail, but surely he can. I didn't see what was message. It was some guy asking like how to convert some like a set of folders into some like I assume archive format. I don't know. Okay, there we go. So right, because we don't actually assign the file descriptor here. I forgot. The file descriptor is sent out of band. So we're gonna have to figure that out eventually. Eventually. But the rest of this stuff should be just kind of from like w zip params offset. What else is he missing? Can I maybe we jump to this and we copy these and paste them here. So we're assuming single plane. Okay, offset, we probably need this. Maybe we should make the types match up. Oh, whatever, I'm fine with doing it this way for now. Stride is equal to int cast param stride, and modifier high is the top 32 bits of this. So we can do params modifier shifted right by 32, and modifier low is int cast of zbb params modifier and what's the easiest way to construct this? By hand, baby. Sure. So now we can't actually just like send this directly because we need to add the out of band file descriptor message. So we do that by doing something like array to send. Easiest way is just write truncate. That's true. I'm down. I'm down for sure. To send is going to be a std array list initialize with an allocator, which we don't have yet, but we will get one. Okay. We will use this as our output. So we're going to basically take the serialized message from this and stuff it into a buffer, because we need to attach this file descriptor for out of band, which is not like kind of hooked up to like the C message or hooked up to like the std net stream. Shift and retains type. All right. All right. Thank you. Thank you. Thank you. Now we have to call, we have this like C message thing. So how have we used it in the past? We have to do something that's very similar to this. Sure. Sure. Yep, this all works. And we are now using the ZWP params FD here. But I think the rest is just like the same. So then we have to create an IO vector and a message header and call send message. And theoretically, this stuff should get factored out, but you know, we'll do that in the future. So fix me heavy duplication with create SHM pool. I don't want to cover that right now, right this second. Okay. Okay. So theoretically, this should send a create. This should send us a, this is an add here. So then we should be able to create now that we've added our plane. So we're going to call here on our params, buffer params, create. And he needs like some stuff, width, height, format, flags. Okay. Width, height, format, flags. Now, width and height, these came from like make texture, right? Make test texture. So I guess that this should take in a width and a height, I guess. This duplication of the P has a name in literature studies, I think, pure poetry. What are you talking about? P. I'm sure what you're saying makes sense. I just can't find it. All right. So here we'll make it like a 640 by 480 texture. Okay. And then we can say width and height here. Our format comes from the ZWP params. Duplication is traditionally spelled with one P, but makes sense in this Oh, did I write it with two P's somewhere? That's funny. 4cc is the format here, and the flag can say it's 0. That makes sense. Oh yeah, that's funny. I missed that. Good eye. Dude, you pay attention to what I write a lot more than I pay attention to what I write. Okay. Okay, let's do a, when we create make text texture, this takes a uint32t width, uint32t height, and this gets passed in width and height here, which means that this stuff is no longer constant. But the rest of this should just kind of work, hopefully. Hopefully. Okay, so now we have to wait for this guy to send us back the created message. So now we have to actually run our event loop a little bit. So we'll make a little event loop handle to run, where the fuck we were just now, main zig. We run our event loop. And I guess, how does this work before in our like bind interface? I think we like wait for, yeah, we retrieve events. Okay. Say, give me some events, and then while it get available event, while there's something that we can do, we need to handle this event in some way. And what are we expecting to get here? Really, we've sent only a few things, right? We've sent create params. I guess maybe we'll just log what we get back for now and see what that looks like. So can we do like log unused event? And so presumably this gives us header and data. Right, so we look at the interface registry and we say which interface type was this for, if we get like event header buffer ID. So we'll call this interface type is equal to this. Is this or else we'll log, I guess, unknown interface, or unknown object, I guess. This shouldn't happen, but it could, so we have to handle it. Now at this point we like have a known interface, so we can say unused event takes in an interface type and an event. And this should tell us what happens. And so we'll kind of run this stuff, and then we'll just kind of like if true return here. And we'll kind of see if it works. He does not, because he expected 4 arguments. That's true. He does need an allocator now. And he's mad because there's no field named modifier in, is it the right type? Struct texture FD, okay. I thought that we did that. Oh, it's modifiers. Sure. I'll allow it. Okay. 732. We need to write try here. That's a good point, sir. And then 4cc needs to be bitcast probably. Probably is right. And then we need another 775 on try here. Not quite all of them. Log unused event also has to be tried. Oh my god. We have to return the GL buffers. That's true. We do have to return them. So I guess we don't have them yet. So we'll just write unreachable or panic to do. That way you can't get mad at me. All right. Let's see what happens. So we got some WLSHM events. Oh, from when we bound to this thing? And that's it? So when we send this buffer params create, we just don't get anything back? Let's try get event blocking. Maybe we're like, we have not, like, it's not ready. Like, we didn't wait long enough, maybe? Maybe? Const event equals it get event blocking. Because I feel like we should get some response from the server indicating that we did something. So yeah, we do. Interesting. So it looks like maybe the socket was backed up or something. So probably before we start running this, we should consume all events. So where does this like WLSHM event come from? Probably when we bind interfaces, we bind WLSHM and he immediately starts telling us that he's got some stuff ready for us. Maybe the play here is we just wait until we receive a create event. That seems reasonable. So we can look for, because I think that like anything that is responding from when we bound before to another interface, we don't really care about right now, I think. We'll see. So here we're just basically looking for ZWP Linux buffer params, which I don't remember what we called on like the runtime side. Interface type. DMA buff params. So maybe we'll just say DMA buff params. We're waiting for something. Once we see a DMA buff params, we're fucking chilling. So here we'll switch on interface type. Whether or not it's a success or failure, like we're fucking donezo at this point. So we break. Else, we log unused event of interface type and event. I don't understand why he's mad here. I guess probably because this thing doesn't need a semicolon. And here we need to parse the DMA buff params response. So DMA buff params event parse from our operation. So event dot header op and the event data. Okay. And if we see parsed, if it looks like a success, we're chilling. And what was the other thing? It was failed. So failed, we have a fucking problem. I guess we'll just like panic. Return error, failed to DMA buff failed, I guess we'll call it. Maybe even just DMA buff. DMA buff create failed. That sounds right. DMA buff create is an error that we did not successfully create a DMA buff. Which makes me think like create DMA buff feels more word correct to me. But if we see success, then our success should have some sort of state attached to them. So this is just and we should be able to say that we are like buffer ID. So we can kind of like store this, like our WL buffer here is what we're trying to get out of this. Is initially null, right? But if we get one, then we can say WL buffer is equal to WB WL. I guess he infers the type, so we can do like ID is equal to s dot ID or something, depending on what's in this. No, it's buffer. It's called buffer. And then at the end, now we should have a WL buffer and a texture ID. We should have both of those things. We should have both of those, which is pretty cool. I think success, no field name success because it's an error union. No. In type info, union tag type question mark. Am I stupid? What's it called? Created. Yeah, that's true. That's true. That is its name. And then error union is ignored somewhere, probably on this log unused event. And texture ID is not the name here, when maybe it should be. Sick. So now does everything else kind of keep working the way it did before? I think we had an if true return here that we don't want anymore. So theoretically, everything else should just continue working the way it used to work. Okay, big win, big win. Now we want to try, instead of rendering whatever we were doing before, we want to pass in GL buffers here. I believe. We will see, but I believe that's what I want. So on our like main initialization now, I think we want to basically disable anything related to like our animation right now. So I think we just don't ask for frame updates. So if we do that right now, does I think we do that right now, it should just kind of show nothing. Great. And then we should try to, instead of attaching like pixel buffers that we create in shared memory, which we don't really need anymore, we can just try to attach the buffer that we got from our texture. So I think it's just like this. Okay, then there's a bunch of use of like pixel buffers that no longer make sense because we're not using pixel buffers anymore. We're using the OpenGL ones. So he's mad that Alec is unused. We'll just kind of stub that up for a second to try to get ourselves compiling. Okay. And then at 564, we are basically going to disable all of this. We have no frame callback work to do right now. We just want to see if something's working. It's not perfect at all. That's pretty funny. Yeah, very, very much not perfect. Very much not perfect. So I'm interested to see what the fuck is going on there. But it's like something, which is pretty good, right? Like we see like the fact that we're seeing anything at all feels to me like something is happening, you know? I suspect it's something related to these modifiers. Just from some debugging, like from some off-screen debugging I was doing yesterday, it just feels like similar to something I was seeing yesterday. That's not the case. Not the case. We could try if plain indexes start at 1. That's a possibility. But if okay, so that's a good sign actually. That if we use plain ID 1 here, he actually just like gets angry at us, which is pretty cool. Pretty cool. I would like to know what he's saying. So here I would actually like to see that if we see a I would like to see the error message, which we can get out of here. So if switch on parsed, I guess here we say yeah, if we have this error, we log wayland error, else we do the normal unused event. Unused display unused event parsed. There we go. There we go. So here he says no DMF has been added for plane 0. So that's a good error. Is the fact that it's partially transparent related? Do we send RGBA and expect RGBA? Maybe. I don't think so. I don't think so, but it could be. I wonder what happens, like hand wavy, if we just like kind of send the wrong thing on purpose. So let's go back to plain, set this to 0. And if we just like send like the wrong file descriptor here, where if we just say like ZWP, like C int this like is a C int of like 5, right? And we just like send this instead. Just want to make sure that like the file descriptor is like correctly making to the other side. And so he gets mad that we never see a created DMA buff. Oh, because he says that like basically the other side is saying that it failed. Right? So we're probably gonna get an error after that. He's saying like oh, he doesn't really error, he just deletes it. So that's kind of interesting. Or he does say failed. He just doesn't say why, which kind of sucks, but we can live with that. So we can probably we have some indication that we are correct. We are at least sending a somewhat sane file descriptor because he's actually trying to display something. I'd be interested to see if I've fucked up the format here. Maybe I was supposed to intcast it, not bitcast it. That's kind of like the same thing. And let's just kind of like for shits and giggles, like try sending something wrong here. So gl impl.c. So we are sending an RGBA texture here, and then we call make texture file descriptor. Oh, let's maybe look at the printfs that come into that thing. So 1, 2, 3, 4, 5, 6, 7. Okay. Stride 2560, success 1, offset 0. I wonder what happens if we change the resolution. Right, because before when we were testing this, we were only kind of using 256 by 256. So I'm curious to see if this has like how this affects the window. So here the wayland Wayland has correctly identified the size. Like, he's respecting the size that we gave him. So that's a good piece of information. It looks to me, just like kind of eyeballing this, 256 times 4 is 1024, right? So our stride is 1024. And it looks like it's kind of just interpreting this somehow kind of strangely, right? You can imagine that it's like, if it's jumping 1024 a line, I'm seeing 4 bands. I don't really know if that means anything. It feels like maybe the color codes, he is not correctly identifying, not correctly identifying the format of the buffer. That's kind of how it just kind of feels to me. So I'd like to see, when we add that, when we sent create, format comes in as a 4cc, but it could be that this is like bugged in some way. So also there are flags here that we kind of completely ignored, i.e. interlaced. Don't know what that means, but maybe we should send that, right? We could try it. Feels related. Zig build. So that doesn't really tell us anything, which kind of makes sense. I would also like to maybe manually try different formats here. So I'd also like to maybe look at what it thinks this is. So we do see AB24 here, which I feel like is fine. Where does this come from? Okay, DRM/DRM 4cc. Can we try like just manually specifying one here, like DRM or GL simple DRM for format a RGB 8888 or something. So we want what did we write? We wrote AB24. AB24, so that's this one. ABGR 8888. ABGR. Okay, no bueno. Is it possible that we forgot our GL flush in here? No. Okay. But maybe like just kind of for good measure, just kind of like huck another one around. Like I don't really believe that this is related, but maybe. Because it feels like uninitialized memory to some extent, right? Just like a little bit. What if okay, gen texture, we create a thing. What happens if we just set everything here to like full red? Right? Like let's see if we can like see any form of like difference. So that's interesting, right? We do see that the coloring matters. Now, stride, I bet you it's that stride is in the wrong units. That's my fucking bet. Right? So here, when we add, it feels like stride is in the units of bytes instead of pixels or something. Like, just kind of hand wavy. Fine. can I do this? Or do I still need the as in there? Whoa. Okay, let's just double check our units everywhere. So offset is in bytes, stride is in bytes. Okay. So what does our stride come in at on the other side? Sorry, my poor little stupid brain. So our stride is 1024. So if our width is 256, stride being 1024 does make sense. But, okay, let's check the other units here. Width, baseplane in pixels, okay. I mean, something just feels like it's like off, right? It feels like it's like for CC, DRM format. I'm pretty, like, I don't know. Is the C side putting in an int? It looks like a guitar star. I did that on purpose, yeah. It could be like int casting issues here with like, 4CC was fine. We tried manually setting it. Can we just like stood debug print WP params? Let's just like fucking see what he thinks he is. He doesn't like that. Oh, he doesn't like this. So where do we print out our thing? My high? Oh, new line maybe? Here. Modifier 0 seems suspect. This seems very suspect. Because we see it printed as a bunch of Fs. Yeah, that would do it. We just weren't returning it. We were not returning the right thing. Oh, baby! Let's fucking go, dude! Let's go! Okay, so I know this doesn't look too crazy, but this is a GPU buffer created with headless EGL, passed as a file descriptor to Kwin. And he re-imports that. That's so something fucking sick. That's actually so fucking cool. Okay. So we should be able to kind of like render a little thing now. So maybe we do let me think for a second. Yeah, so we want it to be kind of like in our application, we kind of just use OpenGL. You know, just like kind of in general. And so I guess we kind of want to make our frame buffer, bind the frame buffer, and then call like GL clear or something and see that have an effect. So we could kind of do the same thing that we were doing before, where we kind of animate something with two buffers. Let's say that we've got an implement to this, and we'll say add an animation. Add an animation. So we should be able to just have these GL buffers, we're gonna want two textures. I guess maybe we don't even really care about the texture IDs. We might kind of care more about the frame buffer IDs. Okay. So what we're gonna do is we're gonna make texture. I guess we'll kind of do this like, we'll have some like return thing. Yeah. Okay. Oopsies. We'll do this like 0 to 2. Index. Okay. And we do all of this twice. Now, just instead of assigning to WL buffer, we assign to IDX here, which I thought we had, yeah, WL buffers. And then when we create our texture, we say GL impl we need a frame buffer binding as well. So this would make frame buffer. Here we go. So here will be like frame buffer IDs IDX is equal to GL impl make frame buffer from our texture ID. And then at the end here, we should be able to just return frame buffer IDs and WL buffers, right? You still have shaders though? We will have to bring that back eventually. So for now, I think I'm just going to try to render an animation with clear. That's kind of my goal for this time. So we had these like frame callbacks here. And we're just going to make it so that on our frame callback, we're going to like run our animation like we were before. But instead of doing like getting the pixel buffer, we're gonna like try to, I guess our GL buffers, he's still gonna have this concept of like active and inactive. Right, so it'll be like get active WL buffer. We'll return a something, I don't know, like this. What does like the other version of this do? We can kind of do something similar to what he did here, but we'll kind of do it, instead of getting active pixel buff, we'll get active frame buffer. So let's return a U32, I guess. Okay. So we are basically just going to call like GL impl GL clear, GL impl GL color buffer bit with a color given by our animation. So this is going to be like animation brightness, which I guess we can just kind of like slap this in 3 times with a 1.0. And before this, we have to bind frame buffer. Oh, fuck. I guess we need like glx with I guess we kind of need to like take this stuff and slap it up here in glmpl so that we have access to the same functions on our side. I guess. I don't know, man. So now we should be able to call. How do we like bind frame buffer? Like this. And this is going to come from gl-impl.this and self gl buffers get active frame buffer or something. That's what we called it. Then we will call our swap. I guess kind of we have to do all of this stuff where we attach the latest buffer and we damage it and we commit it. Yeah. All of this kind of feels right. All of this feels the same. It's just like how we set this thing is through OpenGL now instead of through setting pixels in memory. Cool. And so now all we need here is GL buffers. Cool. Maybe. It'd be cool if that worked. U32 does not support initialization syntax. U35. True. So this needs to be a WB WL buffer. Oopies. Okay, he's mad because there's no field in called WL buffers. Good point. Missing field IDX. We'll set this to 0 initially. That's fine by me. No field named WL buffer at 497. Right. So this is going to be get active WL buffer dot ID, and then we swap. Really? What's he mad at? This is at not 497. Oh, because this is called GL buffers now. I fuck that up all the time. And it's like one of those ones where it's like, I wish the error message. I mean, it's my fault for not knowing, but you know, I wish I knew. Let's pass this in. I guess we'll call this const and then say var gl buffers equal gl buffers const or something. I don't know. It's good enough for now. No field named pixel buffers and 591. Right, so this would be gl buffers and 735. This needs to return by value. Almost there. 735. This is frame buffer IDs. I don't know what the fuck I'm smoking. And connection reset. The params object has been already been used to create a WL buffer. Yeah, because we need to create the buffer params once per iteration of the loop. So it does kind of make sense this wouldn't work. I'm confused a little bit about indentation here. Okay, give me a sec. So where was this? Is here. So on each iteration of the loop, we do just have to create this thing. So this should just be in here. And then the rest should be fine, I think. Okay, so he's consistently showing. Oh shit, it's flickering for you guys. That's not good. That's not good. So what's interesting is it's kind of flickering between the mango and white. Was the white changing? I guess I shouldn't like fucking destroy your guys' eyes on Twitch. On Twitch. I was gonna say Twitter for some reason. So I wonder if we have to bind the texture as well. even though he was already bound by our implementation. I did some research, by the way. Apparently, GLH includes GLX.h. You don't have to define GL. If you don't define GLX legacy, which hints at some point in the past didn't, you still need GLX prototypes. Got it. Got it. Got it. Got it. Yes, I don't understand why the GL clear is not kind of affecting what I wanted it to. Because every time we run this, we are supposed to swap buffers, and every swap, we should end up getting like a different frame buffer to write to. I wonder if the attached, I wonder if like when we convert the texture to a file descriptor, if we don't like hold on to the same thing. Like, if it's not like backed by the same texture forever, which I would have thought it is. So we might have to like keep creating new DMA buffs and keep sending them over on every frame. Maybe. It would also be interesting to try saving the textures as well. Well, actually, let's look at can we log what we're binding here? Binding FBO this. He's never changing, which is not a good sign, to be honest. Not a good sign. So what's going on there? That means that like this index, it kind of makes it sound like we're returning the same frame buffer from both of these. Kind of seems that way. So wayland only wants pixel buffers, doesn't care about vertices, etc., right? Well, we are giving it a texture that we're rendering from OpenGL, is what we're trying to give it. So we do call make frame buffer twice, right? Am I crazy? We call this from within our loop. And can we like std debug print? Maybe we debugger. Maybe that's the play. Break here. Hello. I want a breakpoint like at this return. At 8:45. Okay. Source file is more recent. That's a good point. Okay. Info args. Or can we like print frame buffer IDs 1 and 1? Okay, that's fucking bad. That's bad. So can we breakpoint on make frame buffer? So p idx, we have index 0, p texture ID 1. And can we say p idx 1, p texture ID also 1 again? So something's fucked up here where even though we're running this twice, we're getting the same texture ID back both times. Both the same texture ID and the same frame buffer ID. So like what the fuck is going on there? Gen texture calls GL gen textures. Generating texture, we'll call it. Oops. Generating texture 1. So Oh, I'm a dumbass. It's because we're initializing EGL twice. This has to be initialized one time and one time alone. We're resetting all our OpenGL state between, which is fucking stupid. Okay, so now we have two different frame buffers that we're binding over and over again, so that's good. That's good. Can we make it so that it alternates a little slower? So can we do like something like if can we do like last applied time? So first of all, I want this to be a stood time instant. And I want this to be a now. Because so this should fix some flickering that we're getting. We were kind of trusting the time given by the wayland compositor, and that was causing some flickering before. So I'm just gonna fix that while we're here. We're gonna say time now since self time. Delta ns is this, which means that delta ms is equal to delta ns divided by ns per millisecond. Yeah. Okay, so that should fix this. And then I want like applied time. Zig is so fast and nice. I'm sorry. Why are you apologizing? And we'll just kind of say like const now is stood time instant now. And we'll say we apply this thing now. Fuck this shit. I guess we say a stood debug assert that the parsed is equal to done. Okay. And then we want to say like if now since animation applied time is greater than so if now since then is less than nanoseconds per second, so we'll try to flip once per second just so we can like look at it a little bit more. We will break this block, which means that we need a block label. Else we will say self animation applied time is equal now. There we go. So hopefully that will give us a little bit of less shit. This thing has to be like manually created now because times are not auto initialized. So can we just kind of put the animation is equal to time stood time instant now, and we'll do the same for like last applied time or applied. I can't remember what we called it. Applied time. Good enough for now. He's mad because self time equals 0. We don't need the special case anymore. And I guess we don't need to run our GDB anymore, but fuck it. 1 Mississippi, 2 Mississippi, 1 Mississippi, 2 Mississippi. So yeah, we're actually kind of seeing like no effect, interestingly, when we do any of this. Which kind of makes it seem like we have to create a new WL buffer. It seems like he's not happy with us just kind of reusing them. Which is a little annoying. Ping pong buffer, right? Yeah, we are ping ponging the buffers right now. But I think that we have to actually create one, like right now we're creating 2 DMA buffers up front, and then like editing the textures that we created them from underneath, and then resending, and and then never resending again. And it's possible that he's not happy with that. It's possible. I don't know. I think that I'm going to do some off-screen reading on that. I think that if it does work, since we're not issuing a drawer swap, maybe we need a GL flush. Oh, that's a good point, huh? You know what? I'm happy. That's a really good point. I'm willing to try that before calling it. I was about to call it, but now that you've said that, I do want to try this. Because you are right that there's nobody kind of like asking. Yeah, this is. Oh! Nice. Good call. Good fucking call, dude. Okay, so let's fix this applied. Fuck this applied time thing. And unused block label. Thank you. I was about to give up, and I'm so glad that you caught me right there. So look at that. That is an OpenGL rendered animation right fucking there, baby. That's so fucking sick. That is so fucking cool. So we actually we kind of got there where we have like a Wayland hardware accelerated client written from scratch, right? So what have we done here? We have initialized an OpenGL context using EGL, but we are not doing it the normal way where we create a platform, like an we're not creating like a display handle out of our Wayland window. We are saying, hey, let's just use a display pointing to nothing, right? We're going to use surfaceless rendering, and we will render to a frame buffer manually. And that frame buffer we will take the texture from under him, convert him into a file descriptor so that we can send him to another process, the compositor. And then we just start drawing to our, we've mapped like 2 textures to 2 frame buffers, to 2 file descriptors. We pass those over, and we just keep like alternating between them. That's pretty fucking sick, dude. That's pretty sick. Yeah, I think that is a super good place to call it. I'm not sure. I was like writing this demo app before stream today, in the hopes that we would be able to kind of have like a nice little actual 3D demo. I think that it might not be too interesting to keep going that way. We might kind of handle, we might like defer the rest of this project to happy hours, because I think that we've kind of covered all of the like actually technically interesting parts, right? We've made a Wayland client that does hardware acceleration. I was kind of hoping that I would be able to show something like this where we have like a little monkey and we can like drag and rotate the monkey, like kind of like you would do in Blender here. I was hoping that we could have our like client, like that feels like a good end state for the client setup. But I think that like all that's really remaining there is to like port this code that we wrote this morning and like into our existing application, like just like merge the 2 code bases together and handle inputs. So I don't think that that's like is going to warrant its own stream, its own like mainstream video. So I'll see. We'll see what comes up tomorrow. I might kind of do this in happy hour tomorrow, or we might make a mainstream out of it. Not sure. But I think the next thing I want to tackle is the ability to. I want to make a driver. So that's probably coming up next. I hope that you guys are enjoying watching. If you liked what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. The 2 to 4 segment is like mainstream, so that those are like VODs that get uploaded to YouTube as like, you know, a cohesive thing. And then the happy hours are kind of more like 12:30 to 2, kind of like chilling out, doing things that like cleanup work, or minor things, or like reading, stuff like that. So if you want to check that out, the happy hours are archived on YouTube and Patreon, YouTube members or Patreon. The main streams are archived on YouTube. There's a GitHub link in the Twitch description where the code for this will eventually go up if you want to check that out under the Wayland client repo. Yeah, we'll see. So, catch you guys tomorrow. YouTube, goodbye, and Twitch, let's find someone to raid.